Today we have a very interesting topic, the economics of economics. So this is going to be not just about economics, but about you and what you do and what your motivations are. I suspect economics will be very different if you were doing it for your own sake, for your own business and for publication. And I think that is probably going to be one of the questions or one of the elements that should be very exciting. Dev is well known here and beyond, as most of you are from here. I don't need to introduce him. He doesn't need an introduction. We have seen the bio in the flyer. So I will turn the phone to Dev.
Thanks, Socrates. So this is a part of the early stages of a new project that I'm part of, and I'll mention the other participants a bit later on when we get going. And the economics of economics sounds like promising a lot, and that could cover a whole range of different things, couldn't it? So it's going to be one sort of slice into the economics of economics. And so, as I sort of said in the flyer, the starting point for this is the observation that economists like to give advice, and we give advice to anyone who'll listen, and including to people who won't listen, policymakers, businesses, the public, and other researchers. And we like to think that our advice is valuable, but is it? How valuable is it? And who's it valuable to, and for what? And at the same time, we like to quantify the values of things ourselves. We like to value environmental assets through non-market valuation studies. We like to estimate the value of projects through benefit cost analysis. So we're good at putting the value on things. What about putting the value on our own advice? So that's sort of where I'm going with this. So that's something that's not done very much. There's a very small literature that does this. There's one paper which I was just reading that seems to do this in the area of environmental economics. So we're sort of breaking new ground here. So this is about the value of information. The information that we produce as economists when we do analysis or research or modelling provides information. What is that information worth? So that's going to be the theme, the focus of this talk. And there is actually, conveniently, a standard framework to put a value on information. The problem is it's very complex and quite tricky. So I first dealt with this in my PhD. I looked at the value of information about weeds to inform weed management, and so that was interesting. And it sort of falls in the realm of what's called decision analysis, or sometimes decision theory, sort of on the edge of economics. I guess economists would sort of feel that they encompass that, but people other than economists use decision analysis as well. It's quite widely used in conservation, ecology, and so on. So it's not just economists that use this tool. And it has been used a number of times to try and evaluate the benefits of information generated by research, not by economists, mostly by other researchers, or from monitoring. You know, you're managing a process and you're monitoring how it's going, you're getting information. What's that information worth? But as I've said, it's rarely applied to economics. The second time I applied it after my PhD was this work I did about 10 years ago on the economics of monitoring the development of an agricultural system for whether it was sustainable or not, what environmental impacts were happening. And I'm not going to go into this paper in any depth, but it's relevant because I managed to provide a very simplified, super simplified explanation of how to think about the value of information. So that's what I'm drawing from this paper. One of the things about this topic is that you'll see that it draws from a whole bunch of other research that I've done in the past. So it's pulling things together. So if we want to value information, it's about the effect that it has on decisions is the main source of its value. Okay, so imagine that we're thinking of making a decision about something, about a policy or a management process, and before we make the decision, we have some knowledge that's relevant to that decision. We have some prior information. We're not completely blank. We already have some perceptions about what will happen if we do certain actions to make this decision versus that decision. So our prior knowledge or perceptions, I'm calling that K0. And based on that knowledge and nothing new, just our old knowledge, we could go ahead and make a decision about what we should do. So some sort of identify a best bet strategy, which in decision analysis is called the prior optimal act. So I'll call that S at K0, S for strategy. So this is the strategy you would do if you didn't have new information. And then there's some payoff from that strategy. So pi is my payoff. So that says, what is the pay? This represents the payoff from doing the strategy that I would choose based on my prior knowledge, evaluated using my prior knowledge. And that might not be clear yet. It'll become a bit clearer later. So I'm going to choose what to do using my prior knowledge, and then I'm going to judge how good that strategy is using my prior knowledge. But they won't always be the same. Then we say, okay, well, now I'm thinking about getting some new information to help me make a better decision, to reduce the chance of making a poor decision. So I collect the new information, and one way or another, I revise my perceptions or my knowledge about the performance of the different strategies that I could choose. Okay, so this is called the posterior knowledge or perceptions, K1. And there's a lot of the literature is concerned with how you go from your existing sort of perceptions and knowledge to a new position about what you think you know about these decisions. I'm going to just wave my hands around that. It's quite a complex thing in itself. I'm just going to say we get new knowledge in, and now we think differently. We have different perceptions about what would happen when we choose different options. And so we now choose a different, potentially the same, but potentially different best bet strategy, the strategy at K1. K1 is the new knowledge with the new information. And we have a revised expected payoff, which is the payoff of the new strategy evaluated based from our new knowledge. Okay, so we've done this process twice, before and after getting the new knowledge. And then how do we calculate the value of the information that we collected? All right, so first of all, let's suppose that I knew in advance that the information that I would collect would take a particular value. So it's sort of, this is a mind game really, right? Sort of saying, I'm going to make my decision initially with my prior optimal act. Then I'm going to get the new information, and bizarrely, I know what that information is going to be, right? So it's sort of a bit crazy, but I know it's going to be I1, and that's going to cause me to have this gross value of information, which is the difference between the payoff with my revised strategy and the payoff with the initial strategy, but both of them evaluated with the new knowledge. Okay, so that's a really important aspect. But this is no longer K0. I'm no longer evaluating the old strategy with my old knowledge. I have to evaluate it with my new knowledge. Otherwise, it's not a fair comparison, right? The difference between them could be just due to my knowledge, not due to my strategy, right? But if there's no change in strategy, there's no change in value. So that's one of the sort of the tricks of the game. But in reality, we don't know what the information will be before we collect it. Right, so I've said if we knew what it would be, this is the result. But in fact, it could take any of a whole range of values before we collect it. And so I'm going to say it could take any of n values. And so I'm representing it just as a discrete distribution here. And I'm going to say that I can make some judgment about what's the chance of each of those n values being observed. Right, so I have some preconceptions about what I will observe if I collect the new information. So I can say, well, I think it's really unlikely that it would be this low. It's really unlikely it would be that high, and there's some distribution in between. So this is me making a subjective judgment before I've collected the information, what might come out of collecting the information. And then the expected value, the gross value of information, is this thing, the first equation, repeated for every possible value of the information that I might observe. For lots of different I's, right? So summed over all the possible values of I, what is the difference between the best strategy with the information and the best strategy without the information, evaluated from the position of having the new information, times the probability of observing that particular value of information. I said at the start, this gets complex, right? You can get lost. Your brain can get lost in this stuff, but hopefully you've been able to keep up. But I'll give you a sort of a graphical version of it now, if that's been too much. I've left people behind. So here's another representation of pretty much the same thing. So on the right hand side, I've got no additional research, no new information, no new economic knowledge. On the left hand side, I've got some new knowledge, and I'm trying to choose. The decision is I'm trying to choose whether to do policy A or policy B. If I don't have new research on the right hand side, then I could choose. If I choose to do policy A, I end up with environmental values A, and the R minus means there's no new research. If I choose to do policy B, I get environmental values B, also with no new research. And on the left-hand side, similar thing, policy A, get environmental values A, R plus, and environmental values B, R plus. And the difference between the two pairs of things is, no, sorry, not the difference, take that back. Out of those two, I'm going to choose the best one. So let's suppose that if I do the research on the left, the best one is to do policy A. That's why policy A is bolded. And if I don't do the research, the best one is to do policy B. That's why this one's bolded on the right. Okay, so as a result of doing the research, I'm going to switch my preferred policy from B to A. And I want to say, well, how much better off am I from that? So I evaluate the benefits from these two policies, given what I know now with their information, and that difference is the benefits of the research. I see some people nodding, most people nodding. Okay, cool. So that's the concept behind the value of information. With that framework, you can say quite a lot about the value of information. So you can say, well, I already said that the information, when you think about it in this way, information generates value by changing decisions. If you get new information and it has no chance of changing your decision, there's no value, right? It might be interesting, but if you don't change your decision, nothing's changed in the outcomes, right? So this is very sort of utilitarian, right? It's just evaluating the outcomes that you get from the decisions. The second thing is that the value of information is specific to a particular decision. So for the same information, I'll get a different value of information if I apply it to a different decision. Right, so later on, I'm going to show you the results for a decision where I'm prioritizing from a list of 100 environmental projects. That's one type of decision. Another decision could be, should I do this project or not? Just a yes, no. And I would get different results for the value of information for the two decisions. The third one is that the information that you collect reduces uncertainty, and it's that reduction in uncertainty that leads to the new decision, that leads to the value, right? So this is about reducing uncertainty. You have relatively high uncertainty, you get some more information, it reduces your uncertainty, you change your decision, you have a better result, on average. The next one is that the value of information varies between different situations, and we'll look at some different situations. And it's not always worth the cost, right? So the information sometimes is not worth enough to justify collecting it. If you're using decision analysis to drive your decision making, then the gross value of information, that thing, the equation that I showed you, can never be negative. You can never be made worse off by collecting more information. The worst that can happen is that your decision doesn't change, in which case it's a zero result for value. That's before you consider the cost of collecting the information, of course, right? That's another thing. Yeah.
Doesn't gathering information delay a decision? And therefore you could be delaying.
Okay. Yeah, good point. Yeah, so Ben says gathering information could delay your decision, and that could be you could be made worse off by delaying. Yeah, you could be made better off by delaying too. There's an option value potentially. Yeah. But you're right, that delaying could be a factor. Then the last one on this page is that a necessary condition for the value of information to be high is for the net benefits of your decision to be sensitive to which decision you make. So that might sound familiar to some of you who are familiar with my paper called Flat Earth Economics, which is about the fact that often when you're making decisions, economic decisions, there's quite a wide range of values or wide range of decision options that you could choose that don't really change the value of the outcome. Like that. So here's an example from an old paper of mine where I've got the area of trees. So just replacing cropping with trees in a particular situation. And the net present value is the payoff, and it's very, very flat. So if you've got a situation like that, I could collect more. Let's suppose I'm currently thinking of going for 160 hectares of trees. And then I collect some more information and it makes me change to 40 hectares of trees. Who cares? Look at the net present value. It's the same, more or less. So in a situation like that, that would mean that the value of information is going to be low because whatever decision you make isn't going to have a big impact on your economic results, returns. On the other hand, it could be a situation where the decision is extremely obvious, right? There's absolutely no doubt what the optimal strategy is in that case, and therefore the value of information might be low for that reason. Right? You're not going to change. You're always going to put in 280 hectares of trees, and collecting more information is not going to change that. Sometimes the decision is so obvious that there's no value in collecting information because it won't change the decision. Okay, so a few more insights. We're just sort of milking the framework. Greater uncertainty about non-market values. Okay, we're sort of starting to shift into non-market values here. Mean that there will be a greater value of information, or conversely, greater current knowledge about non-market values or any particular thing that you're trying to value would mean that there's a lower value of information. The more we know, the less additional gain we can get by knowing more as we sort of converge onto perfect knowledge. Larger, more important decisions with more at stake mean that there's a greater value of information. So if I'm making a decision about 1 hectare of vegetation versus 1,000 hectares of vegetation, that will change the value. And if information is less likely to change the outcomes for whatever reason, could be for political reasons, then there's a lower value of information. So here's another extract from another paper. This is on policy-oriented environmental research, what's it worth? Another one where we sort of drew this value of information concept in. And it highlights, this is one figure from that paper, just highlighting that in thinking about the value of research that is intending to influence policy, that is intending to influence behaviour, that is intending to influence environmental outcomes, there's a lot of steps, at any one of which could break down. Right? So we could do research, the top level there, there's a research stage. You do the research, it may or may not lead to the production of relevant information. If it does lead to relevant information, it may or may not influence policy. Policymakers just may pay no attention to you. Even if it does influence policy, it may or may not have a big influence on people's behaviour because the policy might be poorly designed or poorly implemented. And even if it influences people's behaviour, it may or may not achieve the environmental target or a big environmental change. So there's lots of ways in which this type of research that's aiming to sort of have an influence right through a series of steps like this could go wrong, in which case the value of information at that first stage would be reduced. Okay, so that brings me to our new ARC discovery project. So this is with Abby and Michael, Syed, Robert Johnson from Clark University in the US, and 2 new PhD students, Audrey and CJ. CJ's stuck in Sydney in lockdown, but will be here after Christmas. And so this project is really employing this set of concepts. And it came out of these observations that environmental economists interested in non-market valuation tend to like complexity and sophistication and novelty and focus very much their energy and efforts on that. Whereas observing policymakers, they like simplicity and low cost and a quick turnaround. And so there's a sort of a contrast, conflict there. But there's a spectrum of options. If we're thinking about collecting new information about the non-market values of an environmental asset or an environmental project, there's a lot of options that you could choose from. You could go very quick and dirty, or you could go very sophisticated and slow and complex. But there's also other options in between. And so the question that we put in this project is, well, which is best out of that spectrum of options for collecting information about non-market values? It might not be the most accurate, but it could still be the best in the sense of having the greatest net benefits, the greatest difference between benefits and costs. So that was one motivation, one sort of lead in. This is the other one. Is some number better than no number? So there was an active debate, as you can see. These are 5 papers that are all referring to each other and arguing with each other about the question in relation, specifically in relation to contingent valuation, which is one of the non-market valuation methods. Is some number better than no number? And these guys, Diamond and particularly Jerry Houseman, who has another go later on, basically say no, it's not. That in fact, by the time he gets to this paper, he's quite clear. He's saying it's not. You're better off having no number, because he just thinks that contingent valuation is such rubbish, which produces such poor information, you may as well not bother. And of course, all the specialists in collecting non-market valuation information didn't like that, so they were in the fight and fighting quite valiantly, and I think quite well against that position. But interestingly, at no point in this discussion did anybody raise the question, what is the value of the information that's being produced? They're arguing about how accurate it is, but not how useful it is, or how valuable it is when it is being used. And no one raised the point that actually it could be quite valuable, even if it's not highly accurate, right? Which is sort of where we are in our project. How valuable is it, even if it's not highly accurate? Is one of the things that we're investigating. So that was another motivation. All right, so I've sort of flagged this a bit already, that there's a spectrum of non-market valuation methods, from accuracy ranging from high down to very low. So high would be some sort of very sophisticated original study where you go out and do a new survey, or you get do a hedonic study or something. And then down at the very low end would be, you don't do any new work, you don't go and read the literature, you are a policymaker, you just sit in your office and you make a decision based on what's in your head, based on your perceptions of how valuable the environmental asset is. Just your perceptions, nothing else. Uninformed by this type of research, might be informed by other types of research, ecological research or public opinion or something, but not non-market value research. And then, you've got sort of in between, you could do a benefit transfer study. So not an original study, but just reuse an existing result from a non-market valuation study, just extrapolate it to a new situation. So that's obviously not going to be as accurate as doing an original study, but it's going to be a lot cheaper and quicker. So you can sort of get the sense that there's a spectrum there. And the second column here is uncertainty. So relatively speaking, doing an original study is going to give you, relatively low uncertainty about the value that you generate. Whereas if you're just making it up and you're going just on quite crude subjective judgment on the right-hand side, then the uncertainty about the non-market values that you use in your decision is probably going to be quite high. And then the last one is the cost, right? Which is going to be inversely related to the uncertainty. Okay, so I've got the least uncertain on the left and the most uncertain on the right, and that's repeated on this graph, which depicts in a schematic way the idea that we're sort of looking at here, where for the variance of your non-market valuation estimate, in other words, how uncertain you are about the information that you're using, you're very certain on the left-hand side, and you're very uncertain on the right-hand side. And that set of methods, non-market valuation methods, that I had on the previous table are lined up along this axis. Okay. So on the left-hand side, we've got the complex, expensive, non-market valuation methods. And on the right, we've got simple, cheap ones. And on the vertical axis is in dollars. And we've got lines on there for the benefit of improving your decisions. And this is hypothesizing that as we go from high uncertainty on the right to low uncertainty about the values on the left, we'll have diminishing marginal benefits. So the capacity to improve your decision making by getting better quality information will increase, but increase at a decreasing rate. That's the hypothesis, which we will test. And then the other ones doing the opposite. So as we go from high uncertainty to low uncertainty, we're hypothesizing that going to more sophisticated methods will be more costly, and the cost will increase at an increasing rate. Okay. So if you let's just look at the right-hand one of the cost curves. If you compare that to the benefit curve, you can easily eyeball where the optimal is, at V star naught, where the difference between those two curves is greatest, or where they're parallel. And if we were able to get somehow reduce the cost of valuing, getting non-market values, we'd move this curve to the left, and we'd have a new optimal level of accuracy, V star 1. Okay. So that's giving you a sense of what we're trying to do in this study, right? We're trying to sort of play out or investigate the trade-off between accuracy and value and cost for different types of approaches to doing non-market values. So the objectives of this project include to develop a framework to quantify the accuracy. We need to be able to measure how accurate different non-market valuation methods are. I didn't depict that on the graph. Then we also need to be able to quantify the relationship between how accurate they are and how valuable they are. What's the relationship between accuracy and benefits from better decision making? Then we'll need to have a way of quantifying the costs of doing the different types of non-market valuation studies. And when we've done all of those things, we'll be able to explore the optimal choices, like which of those methods strikes the right balance between accuracy and cost. Okay, so we haven't done this project yet, but I have got a little bit of quantitative results to show you for that part of it, the relationship between the accuracy and the benefits. Because, fortunately, I have a previous paper to draw on. This is a paper with Fiona from a few years ago, where we looked at the cost of using poor decision metrics to prioritise environmental projects. I went and grabbed the tool that I developed to do this analysis and have been adapting it for use in the current project because it's basically a value of information tool. And this is really just to get us started. I don't think this will be exactly the tool we end up using, although we may adapt it and some of the ideas might be used. But it's nice to sort of illustrate some of the ideas that we'll be digging into. So this tool is based on 129 benefit cost analyses of existing conservation projects, or of proposed projects, actually. They weren't all existing. And so from that database of 129 benefit cost analyses, I went through them and tried to characterise them according to a number of variables, according to the values of the environmental assets that were being managed in these projects, the effectiveness of the projects, the risks associated with the projects, the cost, and the time lags. So that, having done that, I could get a distribution for each of those things. And that allowed me to generate random new projects that are consistent with those distributions of the variables from that set, that illustrative set of benefit cost analyses. And what I'm using that for, so as I said, what the decision that you do, that you use, that you apply this thing to matters. So I'm doing it for one particular decision, which is to prioritize the best projects out of a set of 100 projects. So what I'm going to do is use the information from this 129 BCAs to generate 100 random projects that are consistent in the distributions of the parameters with the 129, and then I'm going to prioritize those. And I'm going to simulate doing that lots of times and simulate different ways of making the decisions in a way that's consistent with decision theory. And in that way, get an estimate of the value of information. So you'll see how I'll do that in a minute. And I'll also look at how valuable accuracy is. So how valuable is it to use information at all? And how valuable is it to improve the accuracy of the information? All right, so I've got this system for generating random projects which have values, time lags, risk, and so on built into them. And the first thing I'm doing in this graph is I'm saying, what if I'm now going to prioritize 100 projects that I've generated. In one of these cases, because I've simulated this, I know the truth. I can assert that I know the truth because the values that I've generated randomly, I'm going to say those are the real values. And then I'm going to say, well, what if I ignore the values part of this decision? I consider lags and risks and effectiveness and so on. I can have all those other variables are considered, but I just assume that all of the projects have the same environmental values, potentially, if they work, right? So it's like saying that we're ignoring the non-market values. We're just treating them as the same. Or it's also like saying that our uncertainty about the non-market values is infinite, right? Because we don't use any information about the non-market values. And this shows the ranking of the projects once I put them through a benefit cost analysis. So on the bottom axis, I've got the correct ranking, and on the vertical axis, I've got the incorrect ranking that happens when I ignore the values part of the benefit cost analysis. And you can see, and this is specifically of these dotted lines, they relate to the budget of, so it matters how much I'm going to spend on this set of budgets, this set of projects. I've got 100 projects, and I've just arbitrarily said I've got enough money to buy 10% of the total cost of doing all 100 projects. So it's quite selective. And so which projects would I choose? So these have been ranked using benefit cost analysis. So if I was to use the correct full information, then I would choose all of the projects to the left of the vertical dotted line, because they are the highest ranked projects if I use the correct ranking. If I was to choose the incorrect ranking, where I've ignored the values, I would choose all the projects below the horizontal dotted line. And you can see that sometimes that's fine, right? The fact that if I was to use the incorrect ranking, there's a big chunk of projects that I would do that I would also do if I use the correct ranking, right? There's a big, the bottom left-hand quadrant are projects that would be selected in either case. So my using information hasn't changed that. There's no gain there. In the top right-hand corner, there's a set of projects, the biggest set of projects, that I wouldn't do in either case. So that hasn't changed either. But in the bottom right-hand quadrant, I've got a set of projects that I wouldn't do if I did it properly, but that I would do if I ignore the values. So they're a problem. And up here, there's a set of projects that I miss doing if I use the wrong approach, that are good projects, but don't look good if I ignore the values. So you can see that these are the ones, the sort of the off-diagonal quadrants are the ones that are going to generate my value from the better information. All right, so having done that, I identify, okay, with the correct ranking, I do these ones on the left. With the incorrect ranking, I do these ones at the bottom. I know the truth about all of those projects, so I can calculate how much better off I am by doing the correct ones. And for this particular example, it turns out that I am 38% better off by using all the information, including the information about non-market values. Right, so that's one step in this process. However, that's only for one random set of 100 projects. I can generate more. I can generate, in fact, I generate 1,000 sets of 100 projects, and repeat this process 1,000 times and get, well, what's the value of information over that full set? And I get a distribution of benefits from using this information about values. And it ranges from pretty close to 0 to 140% improvement, but the mean is 28% in this particular case. Okay, so there's the process, right? So I can actually get some quantitative estimate of the value of using this information. So 28%, it's not massive, but it's not trivial either. It's certainly worth thinking about, worth having. So in that example, I just did it for a 10% budget, but the budget might be something else. So this is to illustrate that the value of information is decision specific. And in this case, the different decisions, I'm just creating different decisions by varying the budget. So on the left, I've got a very, very small budget, 2.5% is all I've got of the total amount I would need to fund all the projects. And on the right, I've got 40%. And you can see that the more money I've got, the smaller is the percentage gain in value of the outcomes that I can achieve by prioritising my projects. So this is specifically related to using or not using information about values. Right? So if it's a very selective process, I've got very little money, then it really matters that I choose the very best projects. Right? And if I don't get that right, there's a lot at stake. Right? So I can get a 52% gain in that case. If I can fund most of a good chunk of the projects, the gain isn't so large. And you can imagine that if I could fund all of the projects, if I had 100% of the money, the value of the information for this decision would be 0, because there's no gain. I'm going to fund them all. There's no selection happening if I have 100%. So you can get a sense of why the client's like that as you go to more and more funding. Okay. Now this is the last bit. So the last bit of new information, I think. So this shows that the value of information depends on the accuracy of the information. So the graph on the bottom left is the one I've already shown you. That shows you the ranking of the projects if I use information about environmental values versus completely ignoring information about environmental values. And I've labelled that as the CV of the non-market values as infinity. The middle one shows similar, but now the CV isn't infinity, it's 0.3. So the uncertainty is still quite high, but it's not infinity. I am considering the information about non-market values, but that information has a lot of uncertainty attached to it. And then on the right-hand side, the CV is 0.15. So you can see that the correlation between the correct ranking and the incorrect ranking is pretty close. Right? So it's because the quality of the information is getting better, the ranking is getting better, even if I don't have perfect information. All right. So if you look now up to the table, it's the same layer. I've got the different budget levels, and the top one is the value of information under perfect, if I have perfect knowledge, and then if I have imperfect knowledge but pretty good knowledge, the CV is 0.15, and then imperfect information and not very good knowledge, 0.3. And of course, the poorer the knowledge you have, the lower is the value of information from using that information. That's true for all budget levels. You still have the same pattern of the value falling as you go to the right, to bigger budgets, but it falls as the quality of the information falls. So that's nice. And you can get a sense of that our hypothesis that the value of improving the quality of the information might be diminishing in diminishing marginal benefits, looks like that could be true based on those very few results. Right? There's a big step from 0.3. Well, there's a big step from infinity to 0.3, right? Even with this 0.3, that's a pretty big, you can imagine the confidence interval is from 0.4 to 1.6. right? It's a big range of possible values. So this is not good quality information in the bottom row there, but I can still get a 30% improvement or a 16% improvement in my decision. So that's a big step. And then there's a somewhat smaller step in going from 0.3 to 0.15, and a smaller step again going to perfect information. Okay. Now, just to acknowledge, there is a key assumption in those results, which is that I'm assuming that the managers will believe our non-market valuation results and use them perfectly. Okay, so that's not going to happen. And here's another paper where we sort of explored that issue and found that most managers are unfamiliar with non-market valuation, in fact. And although on the positive side, once the concept was explained, many felt that it could be of benefit to use it. So the attitude that we think we're taking in this project, although who knows, it's still early days, but our mindset at the moment is to do it with that unreasonable assumption in order to demonstrate the potential benefits if they did use it. So, because this makes life really difficult to try and accommodate the fact that we don't really know what they'll do with the results. All right. Conclusion: economic information is valuable, especially if current knowledge is low. But there's a balancing act between the benefits and costs of information. We've hypothesised that there's likely to be diminishing marginal benefits from better information, and from other contexts that I've worked in that would also support that hypothesis. We've got a hypothesis of increasing marginal costs, and I'm not aware of any evidence that will help us with that. We'll have to actually do some work to test that hypothesis. But that means that there's some sort of optimal balance between cost and accuracy. The optimal accuracy is going to be context specific, and it might be lower than we think. That's my hypothesis. But I think I'm confident enough to already say that some number is better than no number when you think about it in this way. That's it.
Thank you, Dave. Maybe first we let the people online first go. So you want to first look at the questions here?
Something in the chat.
Yeah.
Greg, you go first.
From Greg, he says, if we heard this uncertainty that do not change the decision, is it still valuable? There's one from Julian also on if we increase the number and potential value of free options, we can increase the number and potential value of free options in an investment decision.
Okay. So Greg's one first. If I reduce uncertainty but don't change my decision, is the advice still valuable? In this case, no. Valuing it in this way, right? Valuing it in terms of the outcomes that are achieved, which is what this approach does, then no, it would have zero value. I'll jump to Greg's other one. Australian governments don't recognise environmental non-market valuation. Is it all of no value? Well, I guess that's sort of a reasonable question. And if that stayed true, then you could say, yes, that is the case. I guess we are, as I just sort of said at the end there, we're part of what we're doing is exploring how valuable it could be if they did use it, and sort of helping them, maybe persuading them that it might be valuable in certain situations to use it where they're not currently using it. Julian Roche, more information can increase the number and potential value of real options in an investment decision. Okay, this is not a real options framework, so I will leave that alone. Another question: what time frame to assess costs and benefits? Time and benefit cost analysis is complex. I haven't specified a time frame. The things that I've said are true irrespective of what time frame you choose. But of course, if you have a longer time frame, then you're dealing with more uncertainty. And the uncertainty about the values that you generate will probably be higher too. It's harder. You can estimate values for the present, but who knows what they'll be in 20 years' time. The society might change, our attitudes might change, people's priorities might change. So that's true. That's something we could think about. whether we want to try and factor that in.
A related question I had is, what type of research are we talking about here? So are we thinking of research that directly informs decision, like the sort of simulation you were doing, or research that he basically generates information, but you don't know how that information is used?
Yes. So sort of basic research.
Even applied, empirical research. So somebody goes estimates the elasticity of demand on fuel or something, but they don't know how it's going to be used.
Yes.
It could be used in 20 different places.
Yes.
So that's sort of a bit removed from decision, but
Yeah.
somewhere it's not.
So it needs to be close enough to decision making that you can draw the link between the information and the decision that's going to be made. If it's just speculative research and it's being thrown out there, in some situations you could probably anticipate that it would be useful for some decisions, but because this way of valuing information depends on the specific information, you have to link it to a particular decision. You have to anticipate a particular decision.
Okay, thanks.
Ben?
Ben?
I suppose a comment. I did some work on value of information, and I found stuff from robotics.
Oh.
So it was quite useful because they have this idea of the belief state, and this robotic vacuum cleaners. So they trundle along, hoovering, and that's productive. And then they reach an obstacle, and then they spend a lot of time gathering information or doing non-market research. Well, they probably don't, but they measure it.
Yes.
And that costs them money, and so they update. They do a Bayesian updating
within the
software,
chip within the vacuum
yeah.
cleaner.
Yeah.
Wow.
And then so it's like they stop, gather information. Oh, I have enough information now.
Yeah.
I've updated my priors. I'll head off again.
Yeah,
Do something
right.
productive.
Okay.
Yeah. So
That's really interesting.
that was useful. And
Yeah. No, I've not looked at the robotics literature at all. Yeah.
So
Yeah. Cool.
Yeah, and I was thinking about, I thought you were going to deal with something bigger than non-market valuation. I was thinking economists generate ideas,
Yeah.
and perhaps non-market valuation is like an idea.
Mm.
And so it's like Robert Peel with the repeal of the Corn Laws. Yeah,
Yes.
that idea, that was one of the biggest sort of welfare improvements
Yeah.
to society at that time. It was due to Peel reading Adam Smith, who had this huge idea. So perhaps non-market valuation is more important as an idea than anything else. That you can place monetary values on.
Yeah. Okay. Interesting.
So then you can do an empirical analysis of before and after. Have decisions improved in countries that adopted non-market valuation?
I mean, the other, I guess that influencing decisions doesn't necessarily require that the information be placed in a formal decision process. It could be influencing decisions in a more, subjective, loose way, just by providing evidence that the community does place a high value on a certain thing.
Yeah.
And then that feeds into the zeitgeist or into the thinking of policymakers, and then they make decisions. Even without reading the literature, they would just say, well, we know it's big, we've got to give this a priority.
I think Hausman was trying to remove that idea from people's heads.
Yeah.
They say, oh, this is all rubbish.
Yeah.
Yeah, just a comment relevant to what happens because the subject is evaluating information, and we're not talking about commercial secrets. This is all public information. That's all public goods.
Yeah.
So there's a layer of value within this framework not recognized, which is public benefits. So it's not directly related to the project, the research you've done, or the policy being implemented, but potentially affecting a large number of research projects down the track in future. I think that's relevant to our discussion this morning about the simple but large immediate benefit type research versus very sophisticated, little application immediately, but potentially affecting research down the road in future. So if that's also included, not sure whether the picture still stay the same or it might be, a larger framework.
Yeah, I mean, that's really going to the fact that research, it's sort of going back to sort of the basic research idea where you put knowledge into a big pile.
Yeah.
You've no idea who's going to do what with it, and they might do nothing with it, but they might do something with it, and much more difficult to evaluate specific pieces of research in that. There have been studies that have evaluated like whole fields of research or whole programs of research, and that they're typical, but that's often not done with a value of information approach. It's often like it can be done ex post, right? So there's a famous study from Australia from the 70s where they evaluated that there's a big benefit cost analysis done of the division of entomology in CSIRO. And so they evaluated the whole program. Turned out the whole program was justified by one project. And only one, and none of the other projects were much good, right? But there was one project that was fantastic. And that's getting into sort of a different sort of way of thinking about value. That's ex post. But it sort of also flags about the idea of just having faith, that you never know which ones are going to pay off. But if you invest enough, there'll be one sort of thing, one big one that justifies the whole effort.
One more.
Yeah.
The diagram you have this, all the projects.
Simulation stuff.
The simulation of the 100 projects. Yeah.
One thing that strikes me is not that we have something mixed up, good ones or the bad one.
Yeah.
Because if they're not perfectly aligned, it's always going to be the case.
Yeah.
It's guaranteed.
Yeah.
The more constrained the budget is, the riskier that you're going to have, you miss out.
Yeah, that's right. That's right.
But we're not that bad. Because even with that, incorrect ranking,
yeah,
you still capture a lot of the project in the right corner.
Yeah, that's right.
Yeah, that's
right.
That,
so the bottom left-hand quadrant has still got most of the project.
Yeah, in a world that
even with a small budget of 10%, you still do pretty well.
So does that give us faith?
You're on the defensive now, Jumbo.
So the question was, does that give us what?
Does it give us faith that we can deliver good outcomes without perfect information?
Without the better research, you do the correct ranking.
Yeah.
You're not missing out.
So this is not using no information, the bottom left-hand quadrant. It's still using information about the time lags, the effectiveness of the research, and several other things, right? It's just ignoring information about the values. If you ignored everything, then the dots would just be an evenly distributed smear across the whole diagram, and the number of dots in any quadrant will be proportional to the area of the quadrant.
So does that depend on the high correlation between other characteristics of the value?
No. There's a correlation between the other characteristics and the benefits of the project, but the value, so the way that I've represented value here is like the potential value if you did it and everything went right. And then you scale it down depending on discounting and depending on probability of success and so on, and the effectiveness of the project. So it's those other things that have been still captured here, even though the ultimate value has been ignored.
So this is identifying good projects. It's assuming that this is done by good economists, right? That's the other part of the economic.
That's where I got to when I said that I'm assuming that the decision makers do use a framework something.
Yeah,
right?
and the economists also generate honest numbers because not all economists
that's true.
generate honest numbers because of the publication drive. So instead of identifying good projects, is there value in identifying bad ones? And the reason I say this is, if you are very cynical about the decision maker, because it gives them the correct projects, they could leave out one and pick one bad one that they have a reason to choose. Okay, then no one would know that that project was just going to be bad. So is there value in identifying the bad decisions first?
Possibly, maybe you could say, what if you
So the
just
things that
stay away from these ones?
Call that Collins class submarine.
Collins class submarines are on the right. Although from a personal experience, you can't be really confident that even that will help. I was in a process in Canberra. We were ranking 700 projects over the course of a week, And we did put aside a little category, a small number of hugely expensive projects that we judged would be really, they were the Collins class submarines. Do not do these. Our advice is do these if you can, but whatever you do, do not do these. The minister chose one of those. We pulled it out of the race paper basket and funded that one. So,
Isn't that interesting, though, David? That's what they did. All the rational decision making was thrown away in favour of something else.
sounds like Steve.
Online, Steve, give me a second.
It's Julian. Hi, David.
Steve, we can't hear you.
Maybe do a chat.
Yeah, could you write it on the chat line, Steve?
Well, we're running out of time a bit, so maybe.
Not sure why it's not coming up.
Where's the chat?
No?
She's better the volume up.
I can't find the chat. How do I do this?
Okay, Steve.
Stop sharing.
Oh, stop sharing.
Stop sharing, and then that window just pops down.
Okay, that's what I wanted. Maybe Steve can talk to me later.
Steve, you can't talk now, I can hear you.
Go ahead, Steve.
Has gone full Okay. Any one last question? Abin, yeah.
Just some observation. I think this is still identity-based execution, then you can value proposition that boosts value. I think it's a big execution, boosts value, then
Yeah.
Then whose interest counts.
Yeah. Well, that's a decision. Whose value are you going to consider in every benefit cost analysis? You've got to grapple with that. Who has standing in the benefit cost analysis? So, but I guess I'm thinking about it in that sort of way that it's the public, right? It's the way that I've approached that. It's thinking about values as a public aggregate maximum benefit for the whole of society. But of course, others who make the decisions might not necessarily choose that as their objective function. Yeah. All right, thank you.
Okay, thank you. Looks like we need a better stamp for that thing, because when you come here, it's not far enough. We need something that stamps out here.
Okay.
Are you able to return that to Michael?
Yeah, I can do that.
Strange, from last time? Audio system,
Sometimes it works, sometimes it doesn't.
the last time it didn't work.